Okay, this is one of the, I don't know, conceptual problems, I guess they would be, that might show up on your test. I don't really have a number for it, but it says shown below, there's two charged particles that are fixed in place. So they're right here. I'm going to highlight them. So this one and this one are fixed in place. Big Q is a greater magnitude than little q for all of them. There's two of them here for both of these. A third charge is now placed at one of these points, A, B, C, D, E. Okay, and at this place that we're going to put it, the net force in this charge due to Q, little q and big Q is 0. So it's like, where could it possibly be? Where is you putting the third charge? So in order for the net charge to be, or sorry, the net force on the charge to be 0, I basically need that this mystery charge needs to have an equal force on it left and right. Okay, those need to be the same. Let's call it F1 and F2. They need to be the same. The thing is, since the force from little q, since the magnitude of little q is smaller than the magnitude of big Q, in order for those to be the same, since Coulomb's law looks like this, basically for this one, this Q is smaller, which means to even out, R is going to have to be also smaller, so that together you could get the same forces with this one. You want this to be the same. Okay, so that doesn't yeah, like the in order for Q1, for the little q to be smaller, the radius for the little one will be smaller too. So whatever I pick, it's going to be closer to little q than it is to Q. So right away I can say it's not C. Just get rid of it. Okay, it's definitely not C, because that is directly between the both of them. From there, I need to decide, well, which ones of these could work. And it doesn't say, by the way. Oh, it says at which point. Yeah, there is only one answer, but it doesn't actually say there's one answer, so you should check, always check. Okay, my first thought is, oh, it's in the middle somewhere. It could be, but we just have to check. So for instance, if let's just say it was B, okay? Let's check the directions at B. If we put a positive charge there, so let's say, so I'm going to use gold for positive, okay? If I put a positive charge at B, it would be pushed away from this one, because that one's positive, and it would be pushed away from big Q, because that one's positive. Okay, those could cancel out. I'm also closer to little q than I am to big Q, which I said it was necessary, so B is an answer. Is it the only answer, though? Let's check. So D, if we put a positive charge there, it would be pushed away from big Q to the left, and it would be pushed away from little q to the right. Unfortunately, I'm closer to big Q than little q, so they won't be even. Okay, so that won't work. Let's make sure a negative wouldn't work either. So let's make sure a negative wouldn't work either. Let's use green for negative. Okay, if I put a negative charge here, it would be pulled towards big Q, but really hard because it's close. And big Q is bigger. And it would be pulled toward little q. So although they partially cancel out, they don't cancel out completely, so those won't work either. Now let's just check what would happen at A and E. Well, at E, if I put a negative charge here, it'd be pulled towards big Q a lot, and it would be pulled towards little q a little bit. Same way, though. Doesn't really matter what their magnitudes are, because if they're the same way, they're never going to cancel out. Same thing if I put a positive there, it would just be to the right. And the same thing will happen at A. You can check that too. So B is definitely our answer for this one. B. Okay. Now this one, they've changed big Q to a negative charge. Okay. So again, I know it's not going to be C at all because it's in the middle. That's never going to happen. Well, B was the answer on the last one. Let's check that one. So I'm going to check with a negative first because I just happen to have green ready here. So if I put a negative charge here, that'll be pulled toward little q, and it'll be pushed away from negative big Q. Alright, that's not going to work at all. I don't even care about magnitudes. It's not going to work. Same thing with D, or if I put positive charges, you can try it out, but it just won't work. So let's try A. I'm going to try it with a positive because I feel like I should make some other colors here. If I put a positive charge at A, little q is going to push it away. Big Q is going to push it or pull it toward the right. I'm closer to little q than big Q, so they should be approximate, or they could be the same magnitude. So A is an answer. Let's just check E really fast. If I put a positive there, it'll be pulled really hard toward big Q. And it'll be pushed away from little q, but not very much. So they're not going to cancel. Same thing if I put a negative there, it'd just be lopsided the other way. So A is our answer for this one.